Okay, so today's lesson is on acceleration, and the AKUD, what you need to know for this lesson are the following things. What is acceleration? What's the difference between positive and negative acceleration? Why are the units for acceleration meters per second squared? And then the last thing you should know is how do you calculate acceleration? So let's start with this. Let's write a definition. So this is topic 1.3, acceleration. There's 1.4 yet, and then you'll have the test. So we got one more to do. And then there's topic 2, yeah. Okay, so your definition for acceleration. Now I've got a feeling if I asked you what is acceleration, just about everybody in this class would say speeding up. Yeah, and that's basically what it is. But the one thing we kind of forget is that acceleration in physics also includes slowing down. And we actually call that deceleration, but in physics it's all acceleration. It's just, yeah, positive and negative a little bit, not quite. So I'm just going to put down for our definition of acceleration, all acceleration is it's a change in the rate of speed. Okay, it's the slowing down and the speeding up of an object. And this is actually, it happens all the time. It happens every time a car is at a stoplight and starts going. It happens every time you're on a soccer field and there's a ball going by and you accelerate to get it. It's very, very common in everyday life. That uniform motion stuff is probably not as common as acceleration is. So, well, I want to just show you, first of all, is the formula for acceleration. So if it's a change in the rate of speed, then we would write acceleration like this. So there's your speed or your velocity, a change in the rate of velocity over a certain amount of time again. And you see the arrows there? So that would mean, again, that those are vector quantities. So guess what? We have to worry about direction when we're talking about acceleration too. Now the units are kind of interesting. So I guess this is kind of the first thing that I'd really like you to know is why the units are the units they turn out to be. So if we're going to go with units like velocity, that's meters per second. And then we would divide that by seconds. So what does that make acceleration units? Yeah, so Maria's actually point is a good one. A lot of us would say, oh, that makes it meters because the seconds are going to cancel. But the seconds in this case don't cancel because it's divided by something, yeah, divided by. So let me just show you why it's meters per second squared and not just meters. So maybe we'll just look at an example. Let's say that we had something traveling a change in speed of 3 meters a second, and that took 3 seconds. So we all know the answer to that is 3 divided by 3 is 1, and it would be 1 meter per second in this case. But how do you get the meters per second? Well, I'll use my green pen and just kind of show you. There would be no problem putting a number 1 under there, right? Because that's what that is, 3 meters in 1 second. And right here, if I put a number 1 underneath that, that probably wouldn't mess any of you up either. Now, do you remember this from math? So let's go 6 divided by 3. Well, we know that in our head. That's 2. But do you also know that 6 times 1/3 will give you the same answer? Right? Okay, so dividing by a number is exactly the same as multiplying by its reciprocal. You're going to flip the denominator, number 3, around and make it a third. So we can do exactly the same right up here. So we can say 3 meters in 1 second times, well, let's flip this around. Well, that's 1 over 3 seconds. Now take a look at what happens when you do your math. You go 3 meters times 1 equals 3 meters. And there you get 1 second times 3 seconds is 3 seconds, right? No, we don't write 3 seconds. We write 3 seconds squared. So that's how the units become meters per second squared, and then 3 divided by 3 is 1. So that our answer there would be 1 meter per second squared. So that's why the units do what they do. And a good way to see that is just with a reciprocal. It's going on there. So when you have a 1 meter per second squared, what does that mean? Sorry. Yeah, what does that mean? 1 meter per second squared. Well, it means that the speed is changing 1 meter every second. So every second that goes by, that's acceleration, that speed is changing by 1 meter per second. So it's 1 meter per second per second. That's what acceleration is. It's always, that's what accelerating is, yeah. So I'm going to just show you a little video clip. If you want to Google it on your own, you can. It's just Google Eureka videos on YouTube, and then you'll find acceleration number 2. And it's a great little video kind of demonstrating what this is all about. Okay, so the next thing you need to just understand is this whole idea of positive and negative acceleration and how that all works. So I find a little chart really goes nicely to kind of understand this. So you can make a little chart like this. And up here we will just write speed. And on this side we're just going to write distance. Okay, so speed and distance. And I'm just going to use some pluses and some minuses to kind of help us with this understanding. So when I write a plus here, that means that an object is speeding up. And when I put a minus here, it means that object is slowing down. And then we also know that we have positive distances and negative distances. Maybe a better word for this is, instead of distance, is direction. That's what it should be. So let's put direction there. So we know some positive directions from our x-axis method and our navigator method. So what would be what are the positive directions? Well, they're north and east. Or in the x-axis method, it was up or to the right. So those are kind of our positive directions. And then our negative direction, west. That is correct. Yeah. There you go. Finally. Okay, south, or we could say down, and to the left would be negative directions. So, okay, so that's kind of a good way to kind of remember, you know, those directions as positive or negative. So let's think about this for a minute. In math, when you have two of the same thing, so let's say you're multiplying a positive number by a positive number, you're going to get a positive number. When you're multiplying a negative number by a negative number, you're going to get a positive number. So in this little chart, that's what you have to kind of remember, is that when they're the same, it's going to be positive. So what kind of acceleration is this when you are speeding up in a positive direction? That's going to be positive acceleration. So we'll just put that down. So if I'm speeding up in a northbound direction or an eastbound direction, or I'm speeding up, or speeding up going to the right, those are all considered to be positive accelerations. What if I'm slowing down in a positive direction, though? That is negative acceleration. So slowing down in a positive direction means I'm getting more negative, doesn't it? So in this classroom here, that's north. If I'm really running fast here, and then slowing down as I go that way, I'm slowing down in a positive direction. That's negative acceleration. It's like I'm getting closer to going the other way, which would be the negative direction there. How about this one? Speeding up in a negative direction. That's negative acceleration. That's a hard one to see because people say speeding up, oh, that's got to be positive. But if I'm speeding up in a negative direction, it's like I'm getting more and more negative as I go faster and faster and faster in that negative direction. That's negative acceleration. And then the last one, slowing down in a negative direction, is positive acceleration. So slowing down in a negative direction. So that's a negative direction. That's south. So if I'm going really fast and then I slow down, that's actually considered positive acceleration. Because at some point I might stop, and then I might even start going the other way. It depends if we're hooked onto a spring or whatever it is. So that actually is a hard one to see, how slowing down in a negative direction is positive acceleration. But remember just your math rules. Two of the same signs, two positives or two negatives multiplied together would be a positive number. Well, kind of the same thing here. So that's the chart I use to keep this positive and negative acceleration straight. Give this a little go. So in front of you, you have this example. We're going to work through two examples of positive acceleration calculations and then two examples of negative acceleration questions. So the first question, this is page 54 of your workbook. The first question says this: what is the acceleration of a car traveling north when it increases its velocity from 20 meters to 30 meters in 3 seconds? Now, one thing that we should probably just review here is what these deltas actually mean. So I don't know if you have a little space on top of your page as well. But we do know what the deltas mean. They mean change in velocity over change in time. But I don't know that it has been stressed enough to you that we can rewrite these deltas as follows. So over here, I have kind of shown you how that looks. So another way to write this formula is acceleration is equal to, and then instead of writing delta V divided by delta T, we're going to write it as velocity final minus velocity initial divided by time final minus time initial. And if you think about that, that makes sense. How do we know what the change in velocity is? Well, we take our final velocity and subtract it from our initial velocity. And that'll give us our change in velocity. So if we were going 10 meters a second and we speed up to 30 meters a second, what's our change in velocity? 30 minus 10 is 20. So we've been doing this all the time, but maybe haven't been specific enough about what these deltas mean. So keeping that in mind, let's look at that first question. So it says, what is the acceleration of a car traveling north when it increases in velocity from 20 meters a second to 30 meters a second in 3 seconds? So I guess the first question we could answer is this positive acceleration? Yeah. The answer is yes. It's speeding up in a positive direction. To do the calculation, you would have to identify, first of all, what is your velocity final and velocity initial. So the question says speeding up from 20 meters. So that would be your velocity initial to 30 meters. That would be your velocity final. And so when you're calculating your change in velocity, you would go 30 meters minus 20 meters equals 10 meters a second. That's the change in velocity. We would divide that by 3 seconds, which is how long that change took. And we would end up with an answer of 3.3 meters per second squared north. So that's our acceleration. So every second that goes by in those 3 seconds, the speed is increasing by 3.3 meters per second. Okay, so that's an example of positive acceleration. Now things get a wee little bit more tricky. Let's look at example 2. So in an example 2, let's read the question carefully. It says, what is the acceleration of a car traveling west when it decreases in velocity from 10 meters a second to 7 meters a second in 2 seconds? Is this positive acceleration? Decreasing in a positive direction is positive acceleration. Oh, sorry, decreasing in a negative direction is positive acceleration. So the only thing to be really careful about is this whole idea of how do you calculate the change in velocity. So again, go to your question and identify. So the 10 meters, that was our velocity initial. From 10 meters to 7 meters, that's our velocity final. Remember, west is a negative direction. So go to your equation then, and you're going to write velocity final. That was 7 meters a second in a negative direction, means it's minus 7 meters per second, minus our initial, which was negative 10 meters a second, because that's also westbound, and that's a negative direction. And then you all know that subtracting a negative is the same as adding a positive. So your math then goes negative 7 meters a second plus 10 meters a second gives you a change in velocity of 3 meters per second, positive 3 meters a second. Divided by 2 seconds, that will equal then your acceleration of positive 1.5 meters per second squared west. And that's consistent with what we know about acceleration, right? Slowing down in a negative direction is positive acceleration. We just proved that with our calculation. Okay. So now let's look at 2 examples of negative acceleration. So here's the first example down here. So the question reads as follows: what is the acceleration of a car traveling south when it increases in velocity from 20 to 50 kilometers in 0.50 hours? So we're accelerating in a negative direction. That's going to be obviously negative acceleration. So it's, again, it's the delta V that's hard. It's the velocity final, negative 50 kilometers an hour, because this is a negative direction, minus velocity initial, so minus negative 20 kilometers an hour, works out to be negative 30 kilometers an hour divided by 0.5 hours equals negative 0.60 kilometers an hour squared. So there, notice that the units are not meters per second squared. They're kilometers per hour squared. That's okay in this case because your speed's in kilometers an hour and your time is in hours. If your time was in seconds there, we would be in big trouble. Then we would have to do a unit conversion first before we could do that. But here, everything is consistent. Kilometers an hour, and time in hours, so it all works out to be just fine. Yeah, it is. Yeah. No. Okay, last one. What is the acceleration of a car traveling east when it decreases in velocity from 16 meters a second to 13 meters a second in 5 seconds? So this is slowing down in a positive direction. That'll be negative acceleration. So again, your velocity final was 13 meters a second. Your velocity initial was 16 meters a second. They're both positive directions, so we just write those as 13 meters a second minus 16 meters a second equals negative 3 meters a second divided by 5 seconds, and our answer is negative 0.6 meters per second east. So here you have sample problems on page 58 of your workbook, acceleration problems. The first question, fairly straightforward. Acceleration of a northbound racing car, velocity increasing from 44 to 66. So we've got speeding up in a positive direction. It's going to be positive acceleration. To figure out your change in velocity, it's velocity final, 66 meters a second, minus velocity initial, 44 meters a second, divided by 11 seconds, answer 2.0 meters per second squared north. Second question is a question that involves a train moving west at a velocity of 50 meters a second, accelerates to 17 meters a second. So we've got acceleration in a positive direction, sorry, we've got slowing down in a positive direction will be, no, sorry. Yeah, so it's negative direction, speeding up in a negative direction. So we'll have negative acceleration there. So we have velocity final is negative 17 meters a second because that's a westbound direction, minus velocity initial, which is minus 15 meters per second divided by 12 seconds. Answer 0.17 meters per second squared west. You don't have to be redundant here. You can just write either the negative and drop the west, or you can keep the negative, or drop the west and keep the negative. Okay, so one of the two is good. Third question is one that involves a electron accelerator, and we get some wild numbers here with the scientific notation. If you don't know how to work scientific notation, go into your textbook again. I mentioned this once before. There's a nice little glossary thing in the back of your textbook explaining how scientific notation works. The scientific notation is pretty easy. If you're dividing scientific notation, you subtract the exponent. So by looking at this question, we know our velocity initial was 0. It was at rest. We know our final velocity of this electron is 2.6 times 10 to the 5 meters per second, and it is in a southbound direction, so that's a negative direction. So we'll put that in for our velocity. And for the time, it hardly took any time at all. 6.5 times 10 to the minus 7 seconds. Oh, that should just be seconds, not meters per second. Okay, so it just hardly took any time at all. So how do you handle the exponents? Well, pretty simple. Grab your calculator, and all you really have to do here is the division of the whole numbers. So you would go negative 2.6 divided by 6.5, and you get negative 0.4. So you get negative 0.4. And then we'll go, now we have to take care of our scientific notation. So we'll go times 10, and then all you have to do is subtract your exponents. So you just have to go 5 minus negative 7, which is plus 12, right? Subtracting a negative same as adding a positive. So it's now times 10 to the 12. And then you think you're almost done, but you're not quite. You have to move this decimal place over 1 to the right, because proper scientific notation always has a number greater than 0 to the left of the decimal place. So if we rewrite that as negative 0, sorry, not negative 0.4, because that's what we're getting rid of. So we'd write that as 4.0, because we need 2 significant digits, times 10, and since we move that decimal place 1 to the right, that exponent number gets smaller by 1. So it's negative 0.4 times 10 to the 11, or 4.0 times 10 to the 11th south. Try the next one. So this next question is a real test in your ability to manipulate formulas. And so I'd just like to talk about that for a minute first. And then once your formulas are manipulated properly, then you will be able to do a question like this. So for the first time, you're actually trying to find the final velocity. And so how would you develop a formula for that? Well, let's start with your original formula. Acceleration is velocity, change in velocity divided by change in time. And then you're going to find your velocity formula, which is delta v is equal to a delta t. But here's where you would go next. You would fix that delta or rewrite that delta. What does that delta mean? Well, that delta means v final minus v initial is equal to acceleration times time. And then you have to isolate v final. That's what we're trying to find our formula for. So you have to get rid of v initial. How would you do that? You do that by adding v initial to it. Negative v initial plus v initial is going to cancel out that v initial there. But since you have done that to one side of the equation, you have to go and do it to the other side of the equation as well. So you have to add v initial to the other side. And so there's your formula for v final. V final is a delta t plus v initial. And if you can get that, that really shows for the first time a real understanding of how formulas get manipulated. And now you are all set. Now it's just a matter of putting your numbers in. And so we'll just go a little bit lower here. So then we would go v final is 0.50 meters per second squared times 10 seconds plus v initial, which was 95 meters per second. And by doing the math, that gives you an answer of 100 meters per second east. So that's the final velocity, 100 meters per second. So the last part to this question then is you take your final velocity, which is 100 meters per second, and you change it to kilometers an hour using your unit conversion method, and you get 3.6 times 10 to the 2 kilometers an hour.